Number of teeth on each of the two equals per gears in mesh is 40. The teeth have 20 degrees involute profile and the module is 6 mm. If the arc of contact is 1.75 times the circular pitch, determine the addendum. Here, addendum is nothing but is the difference between the radius of addendum to the pitch circle radius. So that is RA minus R. So RA represents the radius of addendum and R represents the pitch circle radius. So pitch circle radius can be obtained from by using module, that is the number of teeth into m by 2, which gives the pitch circle radius, that is 40 into 6 by 2 is equal to 120 mm. And here we will have to find out the radius of addendum circle. So by using length of arc of contact is equal to RA square minus R square cos square pi. So here plus RA square minus R square cos square pi plus minus R plus R sin pi. So here the capital R represents gear radius and smaller represents pinion radius, but here both gears having the same radius, so that it is equal to 2 times RA square minus R square cos square pi minus R sin pi. So this is the length of arc of contact. Here R is a known value and pi is a known value. Pi is equal to here 20 degrees. And here we will have to find out the length of arc of contact. Here length of arc of contact is given as 1.75 times the circular pitch, and here circular pitch is equal to module into pi mr. So it is equal to 6 pi. But length of arc of contact is equal to 1.75 times 6 pi, which is equal to 32.9875 mm. Now substitute this value in this equation so that we can get here radius of addendum, which is equal to nearly 126.5 mm, and the addendum is equal to 126.5 minus 120, which is equal to nearly 6 mm. So in the option, the right option is C. C is the right answer. An electrically heated plate 15 cm high and 10 cm wide is maintained at 140 degrees centigrade. Estimate the rate of heat dissipation from both sides of the plate in an atmospheric air at 20 degrees centigrade if the radiation heat transfer coefficient is 8.72 watt per meter square Kelvin. For air at the mean temperature of 8 degrees centigrade, 80 degrees centigrade, take kinematic viscosity is equal 21.09 into 10 power minus 6 meter square per second. Prandtl number is equal to 0.1692 and thermal conductivity is 0.0305 watt per meter Kelvin. Here we will have to find out the heat transfer from the plate. So the heat dissipates in the form of convection and radiation from the plate. For this case, the total heat transfer is equal the heat transfer coefficient in convection plus heat transfer coefficient in radiation into delta T, A into delta T. So where A is the surface area of the plate and delta is the change in temperature and Hc and Hr are the heat transfer coefficients of convection and radiation. So here we will have to find out the heat dissipation from the plate from both the sides, so that the total heat transfer is equal 2 into Hc plus Hr into A into delta T. So here, but the known values are delta T is a known value, that is the change in temperature is 140 minus 20, which is equal to 120 degrees centigrade. And here other known value is the radiative heat transfer coefficient, which is given by 8.72 watt per meter square Kelvin. Now the other known value is the area, surface area of the plate, that is 15 into 10, which is 150 centimeter square, or 150 into 10 power minus 4 meter square. Now we will have to find out the heat transfer coefficient in convection. So that one can be obtained by using Nusselt number is equal to HL by K. But here Nusselt number is given by is a function of Grashof number and Prandtl number. Here Prandtl number is already known value. We will have to find out the Grashof number, and Grashof number is given by G beta delta T L cube by V square. So here beta is nothing but it is the 1 by T mean temperature, that is 1 by 80 plus 273. So this is the beta value, and here length is, so here now all values are known values. G is 9.81 and here delta T is 120 and L is 0.15 meters, and here beta is 1 by 353 and here nu is nothing but it is 21.09 into 10 power minus 6. So from this we can get here Grashof number is 25.4 into 10 power of 6, and here the product of Grashof and Prandtl number is equal 25.4 into 10 power minus 6 into 0.692. So which is equal to 17.6 into 10 power of 6. So this product is less than the 10 power of 9 value, so that the Nusselt number is given by 0.59 times Grashof number into Prandtl number whole power of 1 by 4. From this equation you can get 38.2. Now substitute this value in the formula HL by K. So here HL by K is equal 38.2. So from this equation we can find out the heat transfer coefficient in convection, that is equal to 7.77 watt per meter square Kelvin. So here now we know both the values of heat transfer coefficients of convection and radiation. So now substitute all these values in the heat transfer, we can get here a value of 2 into 59.36, which is equal to 119.7 watt per watts. So in the options, the right option is D. D is the right answer. Propulsion system has to create a thrust of 1 ton to move the system at a velocity of 100 km per hour, 700 km per hour. If the gas flow rate through the system is restricted to a maximum of 30 kg per second, find the propulsive efficiency. Here the propulsive efficiency is given by 2 VA by Vj plus Va, where Va is the velocity of gas and Vj is the velocity of the jet, and here thrust is equal to, thrust is given by Vj minus Va into mass flow rate. Here we will have to provide 1 ton thrust, that is 1000 kg into 9.81 is equal to Vj minus Va is the 700 km per hour into 10 cube by 3600. So into mass flow rate is 30 kg per second. So from this we can get Vj is equal to 534 meter per second. Sorry, it is equal to 521.4 meter per second, and here the propulsive efficiency is equal to 2 into again here Va is equal 710 cube by 3600, which is equal to 194.44 by 521.4 plus 194.44, which gives a value nearly equal to 54.3%, and in the option the right option is A. A is the right answer.